Hello and welcome to Aerotech's Automation 1 Motion Control Platform Educational Series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation 1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, you'll discover how to update your A3200 calibration files to the newer Automation 1 format. My name is Alex and I'm a control system specialist for Aerotech. Like most migration topics, migrating the calibration file from A3200 to Automation 1 might require some modification. So the first thing we should talk about are the conditions that actually require us to modify our calibration files in the first place. Most of your A3200 calibration files will automatically migrate to Automation 1, saving you a fair bit of time. But if one or more of the following conditions apply, then you must manually adjust the calibration file before it can be properly used. The conditions that apply for this include 1D calibration files that use an absolute feedback offset keyword, 2D calibration files that also use an absolute feedback offset column and absolute feedback offset row keywords. If in A3200 the axes use the rollover counts parameter to enable rollover, and if in A3200 one or more 1D calibration tables were specified with no sample distance keyword. So for the next few minutes we will review each of these conditions and how you can update your files accordingly. Before we start, let me first clarify an important topic in the calibration files, and that is which axes are actually being calibrated and how to edit the calibration file to begin with. Editing the calibration file is the easy part. You can just open up the calibration file in a text editor, make your changes, save, and continue. The second one, though, is which axes are actually being calibrated when we look at this calibration table. The calibration file has a keyword called start. This indicates which axis is actually being calibrated. The corresponding number for this keyword indicates the axis the table itself is calibrating. This number starts counting at 1, so the first axis will have a value of 1, the second axis will have a value of 2, and so on. Most often, the axes in a parameter file start counting at 0 for the first axis, so we don't want you to be confused when modifying the calibration file since the calibration file counts differently. So if you were determining which axes actually correspond in the parameter file to this in the calibration file, just know that the first axis starts counting at 1, the second axis at 2, and so on. So while we're here, let's start with the first one. 1D calibration files that use the absolute feedback offset keyword. In Automation 1, the absolute feedback offset value needs to be in encoder counts. This was not the case for A3200. So to do this, open your calibration file in a text editor and locate the absolute feedback offset keyword. Next, depending on which axis is actually being calibrated, in this case the first axis, we need to open up the parameter file and find the corresponding counts per unit value that corresponds to that. So in this case, X is our first axis, and our corresponding counts per unit value is 11.111 repeating. We'll take that 11.111 repeating and multiply it by our absolute feedback offset keyword value. That is then going to be our new value in the calibration file that you can go ahead and save, and that's it. 2D calibration files work similarly. If we open up a 2D calibration file, we can also see that there's an absolute feedback offset row and absolute feedback offset column values. Now, 2D calibration files work a little differently in terms of which axis is actually being calibrated since there's two. We can figure out which axis is the row value and the column value based on this row axis and column axis values. So the column axis is going to be our first axis, and the row axis is going to be our second. So like the 1D calibration, we're going to have to look into the parameter file and find out what the counts per unit value is that corresponds to each of the axes that we're using. So for the x-axis, this is still 11.11 repeating. And for the y-axis, this is also 11.11 repeating. So our x-axis is axis 1, so that's the column axis. We'll take that number and multiply it by 11.11 repeating. Luckily, that math is fairly easy. And for the second axis, we'll do the same. Then we can go ahead and save, and that's all we have to do for this. Now, the third change that needs to happen includes any instance where the axis you are calibrating uses the rollover counts parameter. So first, we're actually going to go into the parameter file again and find the rollover counts parameter. It should be under motion and then rollover. So we are using rollover counts here on the y-axis as well as on the x-axis, So we do need to add the rollover counts keyword to the calibration file for the X and the Y calibration tables. So let's start in the 1D calibration file again. So we'll start off by using the start keyword to initialize the row, and then use the rollover keyword and set that rollover keyword value the same value that's in the parameter file. The 2D calibration is pretty similar. In this case, though, we're going to use the start 2D syntax. And instead of just plain rollover, we're going to do rollover column and rollover row. And likewise for each of those, we're going to go into the calibration file and verify what those are. So 4,000 and 4,000. Then we can save the calibration file. Now, as for the fourth situation, if your calibration file does not use the sample distance keyword, then you will need to add the sample distance keyword to the calibration file. Now, this sample distance keyword, as we can see here in the 1D and 2D calibration files, more clearly in the 1D, this indicates the distance in between each calibration point that the stage is going to have to move before that next calibration point is implemented. So if you are part of this group that does not have the sample distance keyword in your calibration file, then your table is probably in a much older legacy format that is no longer documented in A3200 and is not supported in Automation 1. The older A3200 legacy format lets you specify your table values as a position versus correction pairs without this sample distance keyword. So if we open up an example here, we would have our position value and then the correction point. Position value, correction point, position value, correction point. So what we need to do is convert this into this, as well as add the sample distance keyword. So to start, we're first going to have to go and look at the distance in between each of our position values and correction points. So in between each position correction point pair is 5 units. That 5 units is going to be our sample distance. We're then going to have to remove all of the position data and only enter the correction data. So that's what we can see here. So at 0 units, we correct by 0. At 5, 10, 15, and 20, we're correcting by 0 as well. Then when we get to 25 units, we're correcting by -1. Now, there are a few other things in the older legacy format that you're going to need to be aware of and you're probably going to have to take into account, such as this position unit correction is no longer specified in metric versus English, nor is the correction unit. Now those use either primary, secondary, or just counts. So if you are using one of these older legacy formats, I would highly recommend getting in touch with our global technical support team, and they can help you with more of the nuances that might come from needing to convert from this much older legacy format to Automation 1. Once you have the calibration files and tables converted, then you'll need to upload them to the controller. This can be done by opening up the studio, going to the configure workspace, and going to the calibration section. From here, you can click the configure calibration button to launch the configuration. Now, depending on which axis calibration you need to upload, you can select the browse button to browse and upload the file that you want to use. In this case, we just have 1D and 2D calibration files. There are Galvo power correction files and Galvo 2D axis calibration files as well, but neither of those are affected by needing to migrate from A3200 to Automation 1, so we didn't cover them. After you have this done, just click Save, and yes to start and reset the controller, and then your calibration should be uploaded. We can see that if we open up the axis dashboard and see the little C next to the axes. That indicates that each of those axes is now being calibrated. And that concludes this motion control platform educational video. Thank you for watching, and I hope you enjoyed learning about how to migrate your calibration files from A3200 to Automation 1.